Okay, you may have noticed that the last video got cut off just as I was saying the last two words, which was do exercises 5 and 6. So pause the video right now, go do exercises 5 and 6. All right, welcome back. Moving on, here are the solutions to exercises 5 and 6. 5 was in the back of the book, of course. 6 was not, but pretty straightforward. Okay, remember, anytime you need to pause the videos to look at things, certainly go ahead. Let's talk about polynomial limits of polynomial and rational functions. Guys, pretty straightforward. Limit of a polynomial function is the limits of each of the pieces of the polynomial. The limit of f of x, if f of x is a polynomial, as x goes to c, is just f of c. You just plug in c into every single one. For a rational function, the limit of f of x over g of x, as x goes to c, is f of c over g of c, whoops, as long as g of c is not 0. That's an important distinction. All right. Product rule. Here's a good one. The product rule for limits. And this is a bit tricky. Why do I say that? Well, let's take a look at an example to illustrate the product rule. The limit as x goes to 0 of tangent of x over x. Now, obviously, if I just use substitution, this will be 0 over 0. But what I could do is say that, well, hang on a second. Tangent is sine over cosine. So this is sine x over cosine x times 1 over x. Notice that I just pulled the 1 over x out. But I could rewrite this as the limit as x goes to 0 of sine x over x times 1 over cosine of x. Notice that all I'm doing is shuffling around fractions because order of multiplication doesn't matter. But what's this limit? This is equal to 1. And if I look at a graph of cosine, that's equal to 1. This limit is equal to 1. The product rule says I can separate these. The product rule says I can take the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of 1 over cosine x. And since those are both equal to 1, that whole thing is equal to 1. Okay, let's take a quick look at non-existent limits. Non-existent limits. I need to come up with a timer so that I know when I'm approaching 5 minutes instead of being surprised. The limit as x goes to 2 of x cubed minus 1 over x minus 2. Well, we can't use substitution because the denominator would go to 0. So if I use substitution, I get 2 cubed minus 1 over 0, which is undefined. So what I need to do is I need to take a look at the graph. And so in this case, I'm going to look at the graph of this function, and what I see is that it comes down and does something like this. And I'm going to say that this limit does not exist because it depends on whether I'm coming from the left or coming from the right. It's different, and we'll talk about that a little bit later. All right, I want you to do exercises 33 and 35, and we are out of time for this video.